Sweet. All right, everyone, we're gonna get started. If I could have your attention, please. Hello, everyone. How you doing tonight? I am Mario Loria. This is Orchestructure, our first meeting of 2018. I have a live broadcast going on YouTube right now of the slides, and it's got audio as well. So enjoy your pizza. I have many announcements about Orchestructure. Lots of planning that we've been doing. We've got meetups planned through July already. We're introducing lightning talks this year as well, and many other things. I will get into those a little later during the announcements section. For right now, I'm going to let Chris Short, our featured speaker, get going, and his talk on Go. Chris, take it away.
Thank you. Hey everybody, I'm Chris Short. I'm going to talk to you tonight about Go and enabling it in DevOps. Allows you to go faster. A little bit about me. Well, first, legal business. Everything has a license now, so I have this. Anyways, there's a lot of artwork in here. There's some stuff I stole off the internet. It's not mine. So I work for SJ Technologies. Anybody know John Willis, DevOps handbook author? One person. Awesome. I work with him. He's cool. I was just named a Cloud Native Computing Foundation ambassador. Really big mouthful, but it's fine. I don't know why that advanced. That's weird. Sorry. Better. I also have a newsletter. It's called DevOps'ish, DevOps'ish.com. Weekly newsletter. Read all the DevOps and Cloud Native and open source news, so you don't have to. It's just all on your inbox on Sunday morning. It's kind of nice. It's going to be a problem the whole time. Never mind that. And I'm also the co-lead of opensource.com, their DevOps community. So I've contributed to a book for the open organization. I run the Detroit Go meetup in downtown Detroit. If you're ever down there, this is awesome. I love this. I'm a gopher too. Apparently, we're just going to advance the slides as we see fit. That's fine. This is me in Go form. I'm originally a Linux guy. So what is Go? Those are programming languages. There's lots of programming languages, so why do we need another one? That's a fair question. There's the website version, but basically development started in 2007, so like it's new. Wasn't publicly released until 2009, so the team that put it together was very thoughtful about it. It didn't go 1.0 until 2012. So it spent quite a few years just incubating, getting things right. It's very thoughtful and methodical development method. So who made it? It's made by a few guys at Google. Rob Pike, you might have heard of him, Ken Thompson, Robert Grisham, I can never say his name right, sorry, Robert. And then later Russ Cox and Ian Lance Taylor joined. Okay, great, it's developed by Google by a bunch of really smart people that did things like write GCC, the B programming language, UTF-8. That's the team of people that got together and made Go. Really smart people, seriously brilliant minds, and they did it at Google. So they were trying to solve Google-sized problems with a programming language. So the reason why they made it, 2009, there hadn't been a major, programming language released in a decade. You had Python, PHP, Java. Java was ancient at that point. It's designed with a lot of the modern things that happened in mind, like, I don't know, the internet, cloud networking. Like Moore's law slowing down is a big deal, right? Like, when was the last time you saw a 4 gigahertz CPU? Not in mass production, right? You can get them, but it's not like you're going to get them for your server. They're too unstable. So they didn't handle modern computing well. These other older languages. So Go kind of has a very simple and clean, minimalistic writing style. It's very, very, very pragmatic. It's extremely easy to use, thankfully, because I'm not a coder and I can talk to you about Go. I'm an ops guy, right? Like, I've been doing ops stuff since '95. I didn't write a lick of Go code until last year before. Even now, like, I don't code every day, but I just wrote something the other day with a little bit of help from a friend online. It's very clean, very simple, very minimalistic. There's no header files like C and C++, so you can literally like one application in a single file. You don't have to have thousands of files strewn out across your file system. Garbage collection, very, very clean, very, very efficient, very, very low latency too. A lot of people say, hey, Java has garbage collection. It works fine. Yeah, but not as fine as Go works, right? Like when garbage collection kicks in on Java, things stop working. With Go, it's barely noticeable, unlike Google scaled systems. So that should tell you something. And then fast compile times, that's the biggest thing. Like you can compile a whole Go program to multiple architectures in a matter of minutes. So it's not just x86, it's multiple architectures. So that basically means this comic no longer applies. Sorry, developers. It's not a good reason to have a foam sword fight. It just happens. Time marches on. So the standard library in Go is amazing, right? Standard library is all the things baked into Go right out of the box, right? You install Go on your OS, you have these tools available to you right away. I've never used anything outside of the standard library yet to program. Now, that's not to say there's not tons of great packages and frameworks out there. There are. There's thousands of them. The web framework, suite of tools is amazing. A few I want to point out. Fumped or format, Go format. You import it, format your source code. Done, right? Like there's no, I can't read somebody else's Go code. It's not like Perl, no offense to Perl fans. Perl's a great language and all. It's just not, I can't read it if I didn't write it. So with format, you don't have to worry about that. It's the whole spec is laid out for you. Crypto is like a spot-on implementation of TLS 1.0's RFC, or 1.2, sorry. Log, it's great because if something logs and it's fatal, it just fails, right? You don't have to do anything after the fact. You're saying log and you're saying here's the valid outputs and fatal is one of them, you're done. Like that's it. Net, that's the entire networking stack for Go. You can add on some other things if you want, but literally everything's under that. Like Net HTTP has endless possibilities. Makes Go very good at networking stuff by design. The OS and syscall packages can interact directly with the kernel. Super easy, right? Like you want to exit code, you tell it this is the exit code I want, you're done. There's no crazy rigmarole to like I have to handle some kind of exit gracefully. Nope, just all right there in front of you. So I had a discussion at GopherCon this year with Dave Cheney about like the standard libraries, particularly the crypto package. This is what he said. It just works. It's like an Apple product, but it's a programming language. It just works. It's very well thought out, very well written. They're very pragmatic, like I said. So who controls it, right? Like it's open source. It's the community. Yeah, Google's right there. Okay, Google controls the language. We get it. Most of the people are still at Google that contribute to it. But look who's writing Go code. This is the top Go code writing teams on GitHub as of like 2 days ago for a month. Microsoft writes the second most Go code on GitHub. Ethereum, Apache, all these guys. Look at them. I mean, the actual language is number 9. Kubernetes is above the language itself for Go code. It's kind of impressive. And then you have, AWS just released Lambda with Go, Lambda for Go, whatever they're calling it. AWS Lambda Go is the GitHub repo. So what is Go good at? Well, some obvious projects that use Go, like Docker, Kubernetes, those big ones. I don't want to talk about those. They're kind of boring. We'll touch on Docker a little bit. Container runtimes. Docker is not Docker anymore. Docker's Moby. That's all written in Go. Same with Rocket, same with Cryo, same with Containerd. Those are all written in Go. There's a reason why, right? Like there's no virtual machine there. Go's kind of a lower level language, talks directly to the kernel. If you go on YouTube, look up Liz Rice from GopherCon 2017. Literally in I think it was like 30, 45-minute demo, she built an strace replacement in Go with like 70 lines of code. It was amazing. Like right there in front of everybody. I couldn't do that, but she made it very simple and explained it to everybody. Like I understood what she was doing. That's how quick and easy Go is. It's amazing. The concurrency of Go makes it very efficient at multi-core, multi-thread usage. So what it allows you to do is not have to worry so much about this process has to finish before this thing can kick off. Like you can start all these functions at once. As long as they're not touching some output of another function, they can just go. So makes Go very fast. I feel like I'm saying Go a lot. Maybe, okay. As I mentioned before, the multi-architecture builds, like I can write a Go program, and with a flag change, I can build for ARM, I can build for x86, I can build for, I don't know, S390, whatever that processor stack is. Like it's just ready. There's like 20 of them you can build for. So you don't have to rewrite your code for an architecture. Compiler does it for you. Super handy, like if you work at Packet, for example, and you're dealing with ARM architecture on your Mac, right? You want to run it locally, make sure it actually works, and then you throw it over to ARM and see what happens. So, and the best part is that output that you get is a single binary. Everything is in there that you need, and only what you need is in there. So like you write a 70-line program, it's going to be like 4 megs of code that you can just execute on whatever architecture you compiled it for, and it just runs. You don't need a whole installer program or anything like that. You don't need to worry about anything else. Like if you wrote a web server into there, it'll work. Off it goes. Port 80, whatever port you want. So that one artifact for every deployment is kind of nice. You know, I have this code for this service. It just goes out there. Take this thing from an S3 bucket if you want and deploy it wherever you need it. Really, really handy. Cryptocurrencies. That's kind of a hot thing right now, right? Don't lie, who's a Bitcoin investor? Nobody? No one's mining Bitcoins right now?
Mario's the reason you can't buy a video.
NVIDIA loves Mario. So yeah, like I was like, sort of some cool projects that are doing it. Like Ethereum's like default client is written in Go. I was like, that's weird. Why is that? And I went and I asked one of the developers, I was like, listen, your quote reference implementation of your client is written in Go. Why is that? And there was a language barrier. So I cut some bits and pieces out of his quote, like a lot of bits and pieces. But basically it was the ease of use and the power to communicate the concepts that are in the Ethereum white paper. Some of them were easier to describe in Go code than it was in the actual white paper, like the people. So that's awesome. Burying the lead here. I don't know why this is happening. It's really weird. It's a brand new Mac. I'll blame that. It's not the operator. Couldn't be. No? There we go. Like, let's advance 70 slides. And we're back. I was trying to control this with my phone, but I guess that. Yes, that's exactly what I wanted. Mouse. All right, storage systems. Dropbox. They have a thing called Magic Pocket. Magic Pocket is what replaced S3 at Dropbox. It was last year, I think they finally finished getting off of Amazon altogether. Dropbox has their own data centers now. I think they still have some Amazon stuff for like functions as a service or whatever. But all your Dropbox files are not in AWS anymore. So they needed a system to actually manage like petabytes and exabytes of data. So their prototype that they wrote in Python was something like 35 petabytes of data that they wanted to store through this system like efficiently. And they did it with Python, but they realized very quickly that like, oh, here's a number that we're gonna have to hit like in a year. That's not gonna hit that like exabyte scale. So they had to rewrite it. They rewrote their prototype. They had 6 months to do it. No pressure. It's just everybody's data. 500 million users' data. That's all. It's like, you know, half of China. Or like 4 Americas or something. I don't know. 2 Americas. So they rewrote it in Go. using some of the concepts of concurrency, type-safe language that it is. They did 100,000 lines of Go in 4 months. Released the finished product early. They ended up writing some stuff in Rust after it was in production for a little while, but it's still the vast majority of Go. So if you're using Dropbox right now, you are using a Go service that's serving 500 million people with multi-exabytes of data. How many zeros is an exabyte? 12, 16, something like that. It's absurd. So here are some projects using Go. Obviously, we know about Docker and Kubernetes and OpenShift and CoreOS, but like if you've ever used a Terraform product, chances are you've used Go. Or Terraform, HashiCorp, like those are the big three they have that are using Go. Hugo, website, static website generator. Like if you go to my website right now, it's a Hugo site. One command, compile your whole site, have like 1,000 pages in like 300 milliseconds. Puts it all together. Takes it from Markdown to full-blown HTML, CSS, the whole 9 yards. Compiled, off it goes. InfluxDB. Anybody using that? Monitoring? It's kind of newer. That's all written in Go. GitLab, huge Go user. etcd, which runs on everybody's cluster pretty much nowadays, Kubernetes-wise. That's all in Go. And Istio, Rook, OpenFast, Prometheus. Caddy is rapidly advancing towards like faster than Nginx speed already, and they look to make it faster. It's a web server, so it's all written in Go. Like I really think Caddy will replace Nginx sometime soon if it stays on its current track, because there's just no reason not to. Nginx has kind of gotten big and soupy, where Caddy is very straightforward, right? Like you can use Nginx for almost anything now. So it gets too big, kind of keels over on itself. And I wouldn't be.
I love this term.
I wouldn't be, a Cloud Native Computing Foundation ambassador if I didn't show our landscape, which was just updated. This is brand new, 1.1 today. You need a platform, throw a dart in this general direction. It's funny, I got into a discussion on Twitter. A few people mentioned it to me with a bunch of people about the landscape the other night, and it was just like, back away slowly. You have opinions. They're not as strong as these. So yeah, some people are thinking that this is a little much. A year ago, this was like a great tool to use, pull out, be like, okay, I need something that does service management or observability, right? Like there was like 5 things here. Now there's like 25 things here. So there's some work that needs to be done here. Everyone has acknowledged that. But we keep adding to it. If you follow the GitHub repo, it's ridiculous how many requests they get to, add us to the landscape. Like brand new company just started up, and like GitHub repo is like a day old. All right, so some other people's opinion on Go. You've probably heard enough of me talking about it. I asked a few Go developers I know, so why does Go make you happy? Because I don't know a Go developer that's not happy writing in Go. There might be other languages that they're more happy in, but they're not unhappy. Chris Nova said less is more. Julia, I can't say her last name. Julia said, does a really awesome job making the easy things easy, the hard things understandable. Like that's a big deal, right? Like who wants to sit there and toil with your tools? Nobody does. Who wants to sit there and toil with a programming language, right? You just, I'll just get up and learn another one. Stick with it with Go. Like there's some proverbs that Rob Pike put out a few years ago about like how to program in Go. And it's like really simple. It's like 15 lines. Single sentences. That's the way to do it, right? Like there's instructions on how best to do this. Everybody agrees that the Go format isn't the best, but it's there for a reason. Use it. The last quote I have. Awesome. Comprehensible parallelism that won't shoot you in the foot is Go's most winsome feature. I don't know what that means, but it sounds really cool. Thank you, Liz. I'll ask you what that means later. She dropped it to me last night. I was like, I'll put that in. That works. So let's talk about one time when Go bailed me out. Not too long ago, in a place of work far, far away, actually in North Carolina, I was given this app. This app was doing some kind of Dropbox-like sharing thing, but it was like some kind of authentication with like email addresses and such. It was running in production only, and it needed to be completely rekeyed. It was written by a third-party developer. We didn't have a relationship anymore. And it wasn't like, oh yeah, just swap them out on the Elastic Load Balancer. No. You had to rebuild the whole keychain, put it in the ELB, some of the app servers, and then like one database server needed to like have the intermediate chain replaced or something. It was like a mess, just a total mess. Here you go. So certificate chains need 3 pieces. Like I do this as a lightning talk, but I don't go that fast. The certificate chain needs 3 pieces: public, private, and then the intermediate piece. Like you want this. You have to have those in the right order. But when you go to the documentation to figure out what intermediate key do I need, you get a list of these. They don't give you that when you get your cert most of the time. So like, okay, I'm just going to pick this one of 6 and see which one works. And oh yeah, they all live in one file, and they have to be in the right order. And the statistical possibilities of making this work right is next to none. So you can sit there with Nginx, or you can do the smart thing and build a tool and go. So what I did, took some code, 40 lines of Go code, helped me validate, confirm, and configure correctly to get that A+ rating from whatever auditing scanner we needed. One package, point to the files, compile the program, done. So the log package was awesome. It's pretty self-explanatory, enabled logging through your whatever you're logging to, but it had three helper functions: print, fatal, and panic. Panic obviously is bad. Fatal is what I wanted. Like if the thing wasn't built right, the keys weren't put together in the right order, just fail. Nginx would just start. Apache would just start. Then you have to scan it, and then it would fail. I just wanted to fail out off the gate. I totally skipped a slide. This is amazing. All right, we're doing it this way. That better? There you go. Gives you a whole another 5 pixels. So yeah, really sorry about this. Anyway, so the crypto TLS package. Like I said earlier, it's the TLS 1.2, like as specified in the RFC. It doesn't make any assumptions or jump ahead, do something out of the box wrong. It's secure because it doesn't do those things. So, Heartbleed, all these things. Yes, this would have been affected if it was using OpenSSL, but I don't think it was. It didn't use any of those libraries. So you didn't have to replace your Go web server stuff, which was nice. My mouse works. Here we go. All right, so the net HTTP package, as you can imagine, that serves the actual connection over TLS. The one thing I like about the specification here is that if the certificate is signed by a certificate authority, the cert file should be the concatenation of the server certificate, any intermediates, and the CA certificate. What it doesn't mention is in the correct order. If it's out of order, it fails. Because if it's out of order, you're not going to get that A+ rating. Your auditing team's going to hate you. You're going to be in somebody's office talking about, why didn't this work right? Oh, we forgot to test it. You only gave us a day to work on this. This really was a shit project, Ross. Thank you. So you don't have to have those discussions. I have this main package, which is kind of obvious, but it does 3 things: muxing connections, configuring the actual web server. So all those various keys that you can accept when you're, serving out TLS packages or TLS traffic, all the algorithms, crypto, everything else, it handles all that for you. You just specify which ones you want. Off you go. It kind of lines up perfectly with the Mozilla secure config generator. If you haven't heard of that, like literally Google that. And it's awesome, right? Like you tell it what web server you want, tell it what version you want, and it gives you a secure config, like right there. Copy, paste, done. You don't have to worry about like reading the manuals anymore. Reading the man pages, forget it. You're done. Server package just tells you what port to listen on. It's kind of nice. Some mouse would work. That'd be nicer. All right, so if you've heard one of my talks before, like DevOps Days Detroit 2 years ago, you kind of know I have a thing for nukes. Sorry, like that's like I have a thing for failure. And like the most catastrophic failure is like if a nuclear weapon goes off, but the science that has gone into nuclear weapons to make that failure happen is amazing. Like decades. Like, you know, we've been on the verge of like all out nuclear winter so many times, but a lot of people don't know about. So like if a nuke goes off, that's bad, right? That's a failure of policy, a failure of humans, or a failure of an actual device. So it's kind of like why I like DevOps. I really like failure. DevOps is all about failing fast, failing gracefully, failing and not blaming anybody. That's kind of nice too. So that log fatal, when these two things are out of order, perfect. That's what I want. Don't try and do anything else. This doesn't work. Break, done. This, for those not watching at home, this is the public key. This is the private key. This public key has to have that intermediate cert above the actual public key. So if you put it in the wrong order here, because you're trying to pull one of these 6 things, and only one of them is valid, it tells you. So if it's not right, it fails fast. Like, you can't read this, I'm sorry. Go to my GitHub repo, there's the whole program. Like, that's all the Go code needed to test certificates and serve them publicly on the web. If you go to ssl-tester.chrisshort.net, that's what you'll see. Hello world with an emoji. Yes, Go supports emoji. That's why I love it so much. That reason alone. I use emojis in my git commit messages, sorry. If your terminal doesn't support it, get one that does. But like, there's the test from it the other day. A+, configured correctly. TLS 1.2, all good to go. So, I love Go. 40 lines of Go saved my ass one day. It's kind of nice. Compiles less than 6 megabytes. The whole package is there. That's it. All you need, 6 megs. Safely deployed to any public server. Can be tested. Can be audited. I'm sure no one's actually load tested it. I'm sure it'll take thousands of connections, whatever that poor little GCP instance can take. So yeah, keep calm, learn Go. And I always like to end my talks with a quote. This is one from Bob Pike. Clear is better than clever. I feel like that applies no matter what you're doing. You can be clever if you're a comedian. If you're doing computers, clever's probably bad. Unless you're a hacker creating a new Bitcoin or creating a new ICO and then bailing on everybody's money and then just leaving the word penis on the page when you're done. Y'all hear about that? That's pretty epic. Like, started a new cryptographic currency, had all these people, like $45 million of investment, and then they took the money, ran, shut everything off, and just left one page. Literally, text of the page, penis. That was it. Walked off. Find it on Reddit. Great. Thank you.
So before you switched to Go, were you a Python or Perl or Ruby person?
I was a nothing person.
Yes,
I really was just operating with what was around, right?
I mean, the features of Go sound great, but it's like when you're dealing with somebody, if you have a team of people who know Python heavily or Ruby.
I mean, here's my thing, right?
Yeah.
Like, it doesn't matter the tool you're using, but if you're gonna have to pick a tool, try Go. Or like, if everybody on your team knows Python, do it with Python.
Yeah.
If everybody on your team knows Ruby, do it with Ruby. But if somebody on your team is like, hey, I heard of this new thing called Go, let them run with it.
Yeah,
You will be very happy with that choice. Like, don't resist it. Just let it go. Literally, go. So I brought a bunch of swag. Some of it's from the Detroit Golang meetup. Some of it's from my newsletter. Some of it's from George. Most of it's from SJ Technologies, my company. So feel free to help yourself when you're on your way out. Appreciate you having me in. And over to you, Mario.
So if anyone has questions.
Oh yeah, sorry. Does anyone have questions?
Go ahead and ask them.
Like, he got it. Oh.
We're just doing it on the code. We're gonna hang around until
Yeah, sure.
I kick you guys out anyway, so it's fine. Oh wow. Oh.
Ooh. What?
Fidget spinner. All right, I'm done. Come out here. That's all I wanted. This is fantastic.
Sorry, Jeff.
Is it a Go fidget spinner?
No, I wish.
Oh no, it's the new company he works for. SJ
Yeah, SJ Technologies.
Cool. What are you doing there?
So I didn't mention that.
Yeah, come on. Yeah.
I'm a really bad salesperson, so I don't do sales. I'm a senior DevOps advocate. That's kind of a weird term, but who knows a good DevOps engineer?
What?
Yeah, exactly. Like you're not supposed to have a job title with DevOps in it. So basically what I do for our clients, come in, we'll assess, what is valuable to your company, like, and then how bad your code release process is, your lifecycle development for all your code. Hey, like this thing provides value, this thing provides value, but all the stuff in the middle, except for this one person that's actually pushing the button to deploy it, like not worthwhile. So optimize towards what makes you better. So I help companies implement better DevOps practices. We use dojos, Kaizen, and I'm forgetting one word, Kata, Toyota Kata.
Yep.
Dr. Mike Rother wrote the book on that. He's from University of Michigan.
Okay.
So yeah, we do a lot of that for people because a lot of people are just they've been doing the same thing over and over for years and layering on top of that for years.
So I was going to say, what is like the
that.
number one thing you're finding that people are doing wrong or trying to approach in maybe not the right manner?
So
not that there's a binary
right.
yes or no, but
So the one thing that like I realized earlier this year, like I guess earlier this month technically, feels like it's January 74th, I swear. Like we as technologists, right? Like we all work on new cool stuff, right? For the most part, right? Like some of us are still stuck on like COBOL or whatever, but that's fine. That makes you money, go for it. But like we embrace new technology, but we don't embrace changes very well because we're human, right? Like we have to get better as technologists embracing changes, not just to like, yeah, I'm going to keep using Mac and Vim and whatever other tool sets I like forever. Like I'm never going to change. Like we have to be comfortable with saying this email client sucks. I'm getting rid of it. I'm going back to Mutt. Simple things like that. When you're doing that every day, like analyzing your workflow and figuring out what works a little bit better, and you start applying that further forward into your organization, it breaks down some of those walls and silos a lot quicker, like embracing that change and saying, no, we're doing this for this common good, for something that actually provides value. Just because you've done this the same way all the time, and if I show up in your organization, you're probably not in the best spot, right? So embracing change is something that you've kind of already known you need to do. So, if you see me walk in the door, that means change is coming, whether you like it or not. So, I mean, that's not to say, like, some things are fine, right? Like, we can show up and we can look at everything and be like, change that, you're good. Some people just want, like, that good annual assessment of, like, how they're doing. That's great, right? But most of the time, it's people that are like, hey, it takes us 3 years to deploy something. What's wrong? Like, I was just talking to a company in downtown yesterday. They've been working on some project for, like, 6 years. Hadn't even released the production yet and just abandoned it. Like, Jesus, we don't even care anymore. Just get rid of it. Flush the whole thing down the toilet. 6 years, like, dozens of people's work. Just said, it's not worth it anymore. Like, that is what I try to get people to do. Like, to realize, like, the problem is not how you're doing things. The problem is the way you're doing things, right? Like, you can write code. You can use whatever laptop you want. It doesn't matter. It's the process that matters the most, right? People, number one. Process, number two. Tools are like a distant third.
okay. So like 30?
Close enough. 33.
Yep.
Yeah.
Cool.
Awesome.
Awesome. Thank you very much, sir.
Thank you.
And I'm going to stop the broadcast
Okay.
for now. Thank you for all that are watching and tuned in. Most of the announcements I'm about to mention will be posted to the meetup page and